Welcome everyone. In this video, we're going to be differentiating the function a to the x. So that's the exponential function where we're assuming the base a is positive. So let's take a look at this slight change of the formula before we dive into this chain rule version of this. So this is the chain rule version of the formula a to the x. So suppose you want to differentiate the function a to the x. So that would be a to the x times ln of a times the derivative of that term. And that's what you see here in the chain rule version of the formula. And derivative of x is simply 1. So we can say that this is the formula if you have to differentiate a function that is a to the x form. Now let me show you a quick derivation to this, and then I'll come back to this chain rule version of this formula. So let's recall that we know that a to the x can be written using the natural base e. So we know that this is same as e to the ln of a to the x. Both sides are equal. Now here I'm going to apply a little bit of laws of logarithms. Now for laws of logarithm, this can be pulled out on the front and make it into a product. So if I do that, I will have e to the x times ln of a. Now, of course, ln of a is simply a number, so you can rearrange them this way. This is e to that number ln of a times x. So you can think of it as e to the x. So if you recall from earlier that the derivative of the function e to the x is simply e to the x. That's what we're going to use here. So let me show you how to do that. So now, if I want to differentiate a to the x, well, it's same thing as differentiating this. So let's go ahead and do that. So if I want to take the derivative of a to the x, we saw that this is same thing as writing the derivative of e to the ln of a times x. And then here, I'm going to take the derivative. So derivative of e to the function is just simply e to that function ln of a times x, but times the derivative of this function right here. So the derivative of ln of a times x, well, that's simply ln of a. And then again, rewriting this portion right here, we know that is exactly same as a to the x. So I can replace that, and this would simply gives me a to the x times ln of a. So that's the derivative of a to the x. As you can see it, we wrote that earlier of this video. Now, to generalize this formula, we have this on the right-hand side, the chain rule version. If u happen to be the function other than x, then the derivative of that is simply a to the u times ln of a times the derivative of what's in the exponent. So that's what you have to remember. Let's go ahead and work out these problems. For number 1, y is equal to 2 to the x. So using the rule we wrote down above, we're going to find derivative of this. So we know that dy dx is simply, it's 2 to the x times ln of 2 times the derivative of that. Well, we know derivative of x is simply 1. So if you want, you can ignore that, but this would simply be the answer, 2 to the x times ln of 2. So that is our dy dx for this function. Similarly, for the second one, if you want, you can do a U substitution, but I think we can follow this through just by simply doing it mentally. So dy dx on the left-hand side, right-hand side, we differentiate this. So 3 to the negative x, well, that's simply 3 to the negative x times ln of 3, because that's the base, times the derivative of that, which is derivative of negative x is simply negative 1. And then by rearranging the terms, we have negative 3 to the power negative x times ln of 3. So that is our derivative for this one. For the last one here, if you don't see that, that's also by done how it is given in previous two. But if you want, you can do a quick U substitution. So why don't we go ahead and do that? So let's approach this differently. Let u be equal to just what's on the exponent, that's x squared. Then the derivative of u with respect to x is simply 2x. So that's my quick U substitution. That means now I can rewrite the function as y equals 4 to the u. And if I differentiate this, I get dy dx is equal to 4 to the u times ln of 4, because that's our base, times the derivative of the exponent function, that's du dx. So that's the chain rule version of this. And simply plugging in what u and du is, this is equal to 4 to the u, that's x squared, times ln of 4 times 2x. Now that's good enough, or if you want to clear things up a little bit, you can say this is 2x times 4 to the x squared times ln of 4. That will be the final clean answer.